Hey guys, so we are going to continue with our part 2. So, we are on concept E at the moment, which is rotations. There are some little neat tricks I'm going to teach you for rotation. So when you are rotating, you have to pay attention if it's clockwise or counterclockwise. So remember, if you are starting with a point here, so let's say this is our original A, B, C. Actually, that is a bad shape to use. We'll use my original funny shape. So here's my original shape. We have A, B, C, D, E, and F, okay? So I chose a pretty simple shape, but a lot of points. So I want you to think about when you were rotating, if you were going this way, that is clockwise. If you were going this way, that is counterclockwise. Okay, so just keep that in mind. So when you are spinning or rotating your shape, you will see a big R, so remember that, that's important. The big R notation is telling you which way to rotate. If it is not specified, the center of the rotation is always the origin. So if it's not telling you rotate at point or from line 3 or x equals 3, then you're always going to rotate from the origin. So that's what we're going to start with. And remember, that is the origin right there. If the center of the rotation is not the origin, it will be named like this. So in this case, it's saying that we would rotate 90 degrees from point 2, 4, which would be up here. Okay, so just keep that in mind when you're rotating. So next thing is I'm going to show you a little bit of a cheat sheet trick. So when you are rotating 90 degrees or 270 degrees, that means that you are changing your x and y's places and making your y negative. So you're going from x comma y to negative y comma x. Now, you may be wondering, why 90 and 270? So I am going to explain. If you were going 90 degrees counterclockwise, so that would be this one, counterclockwise, and this side is clockwise, you are going 270 degrees clockwise, okay? So it's just an easier way to remember it. When you go 180 degrees in either direction, you have xy, which will then change into negative x, negative y. And then when you go from 270 degrees counterclockwise or 90 degrees clockwise, you have y, negative x. Okay, so keep those things in mind. Now, I have my A, my B, my C, my D, my E, and my F. Okay? My A point is 1, 4. My B is 2, 4. My C is 2, 3. My D is 3, 3. E is 3, 2. And F is 1, 2. Those are my points. Now I'm going to show you my primes. So in this case, we are going to rotate 90 degrees clockwise. Okay, so 90 degrees clockwise. Go to my clockwise, find my 90. This is what I'm going to use. So my X and my Y are flipping places, and my X is becoming negative. So we have, scroll in a little bit so you can see a little better. A prime will be 4, -1. B prime would be 4, -2. C prime will be 3, -2. D prime will be 3, -3. E prime will be 2, -3. And F prime will be 2, -1. Now that I have all those points, I'm able to plot them. So, A prime will go to 4, go to -1. Don't forget to label your numbers. B prime is 4, -2. C prime is 3, -2. D prime is 3, -3. E prime is 3 or 2, -3. And then 2, -1. So as you can see, my shape is still 1, 2, 3 boxes large or in size. Same as my original. The only thing that's happened is it's been rotated. You guys will only have to deal with those solid numbers, the 90, the 180, and the 270. So if we were to practice, we are doing a rotation of 180 degrees across the origin. So, again, if we have our original, our A, and we're going 180 degrees, which means if we go back to this page, you will see 180 degrees, -x, -y, we are just changing our points. So if we have -1, 1, we're now going to have +1, -1. If we have 2, 3, oops. Oh yeah, no, that's it. So we have 2, 3, we're going to have -2, -3. And then we have 1, 4, which will now be -1, 4. A. You can see how if you flipped it a full 180 degrees, it would be in the same spot it is right there. Okay? So, finally, we have dilation. Dilation is when something is getting bigger or smaller. So, oops. If I have a, technology is not my friend. So I have a box. And this is 1, 1, 1, 1. And then my box gets larger. And now we're at 3, 3, 3, 3. Or my box gets even smaller. And we're at 1/2, 1/2, 1/2, 1/2. The shape is not changing, only the size of the shape is changing. And that's what's important. Shape does not change. So, don't worry, y'all. I got some help with that too, okay? So, when you have a dilation, your original point will be xy. Your new point will be cx, cy. Think about when we do algebra. When you have a number next to a variable, what do? You multiply. So, if this is my original, if this is my original, this purple box right here, and I want to know what I have to do to get to there, I know that I'm going to multiply each side by 3. If I wanted to know how to get to here, I'm multiplying each side by 1/2. Okay? So when you have an actual point, right? An actual point, you will be doing it. You don't have to do this one. Because or this one. I'm just going to show you in a practice. So, given the dilation, x is 8 negative 2 under d to the third. D to the third is what's important. You're dilating by a positive 3. So that means you have x 8 times 3, comma, negative 2 times 3. 8 times 3 is 24. Negative 2 times 3 is negative 6. This would be your x prime. Okay? So remember, it's just your xy, 2 c times x, y times x. Okay? So your next question says, give the dilation of x negative 2 under dilation 3, 2 to the third. So your scaling factor is 3. The center of the dilation is going to be 2, 3, that point, okay? So your scaling factor is 3. So now you may say, what exactly does that have to do with anything, right? So you have to find the distance from the center of the dilation before you resize the image, okay? So basically, the distance in x is 8. So we have distance in x is 8 minus 2, which equals 6. Because because that's the distance from this number to that number. The distance in y is -2 minus 3, which equals -5. That's the distance in your pre-image. So the distance in x is 3 times 6. So start here, right? We have 6. So x equals 6 times 3. Y equals -5 times 3. We are multiplying by 3 because that is our dilation factor. So you end up with 18 and -15. Once you have this, you can find your actual point. So your next step would be to do, or to add back in that original point. This original point right here, you're going to add back in. So now you have x is 18 plus 2, comma, y -15 plus 3, x prime will be 20, -12. Because you need to multiply that distance. Don't forget that, okay? So, on to the next one. If a point has to do more than one thing, so this is called a composition. It's meaning that you rotate it and then you dilate it, or you rotate it and then you reflect it. Those are called compositions. So your pre-image is always A, right? Or B or C, whatever the letter is, but it's just a letter. Your secondary image is your first transformation. So that would be A prime. Your next transformation would be A double prime. You can do one of two things. Say we have x is 2, 4, right? We are going to rotate 90 degrees, then, then reflect x-axis, then dilate by 3 at 0, 0. So if I'm going to do all those three things, first we have to rotate 90 degrees, right? So our first rotation, or our first move, when rotating 90 degrees, we're going to go clockwise. You're flipping your x and your y, and your x is becoming negative. So A prime would be 4, comma, negative 2. That would be your A prime. Now I need to reflect over my x-axis. Going to reflect over my x-axis, which, if you remember, means that my x and my y are flipping, or are staying where they are, but my y is becoming negative. So remember, this is my new x and this is my new y. So my A double prime would be 4, negative, negative 2, which equals 4, 2. I'm really sorry, guys. I think it's my bracelets on my screen that is causing this to be all crazy. Okay, so 4, negative 2. So now my final is to dilate 3 over the origin, or by the origin, right? So since I'm not adding or subtracting any point, I can just add 3. So my A triple prime would be 4 plus 3, 2 plus 3, which will equal 7, 5. This would be my final point, and this would be my final prime. So it would be A to the 3rd prime, or triple prime, okay? So just a few more steps. So composition skills practice. All you need to do is write out these points. I don't expect you to plot them. So we have C, 3, 2. We have B, 5, 0. And we have a 2, negative 1. Those are my original points. The first thing I'm going to do is rotate 90 degrees. When I rotate 90 degrees, I am doing what? Take a minute, think about it. When it does not tell you which way you are rotating, always go clockwise, okay? But it should usually tell you. So we're going to rotate 90 degrees clockwise, which means our x and y are changing positions and our x is becoming negative. So A prime would be negative 1, negative 2. X and y changed positions, my y became, or my x becomes negative. B prime would be 0, negative 5. And C prime would be 2, negative 3. Now we are going to translate, or not translate, slide, or, well, I guess it is translate. Translate or slide our numbers 2 by 3. So when you're translating and it is written like this is your H and that is your K. So that means that A double prime will be negative 1 plus 2 and negative 2 plus 3. B prime will be the same thing. So you have 0 plus 2 and negative 5 plus 3. And C prime, or double prime, will be 2 plus 2, negative 3 plus 3. Our new points are going to be 1, comma 1, 2, comma 2, and 0, comma, or 4, comma 0. Whew, my brain is not working today. Okay, so those would be your new points. You would be able to plot them on the thing, and your triangle would end up somewhere around here. So, by looking at the rule, you should be able to identify the transformation. If we go from xy to 4x times 4y, or 4x 4y, we know that this is a dilation because we're multiplying. If you go from xy to x negative y, what are you going from? Or to, should I say? That is a what? A reflection. So when you do a reflection and you have a negative y from your original, you are reflecting x-axis. What about when you do xy to x minus 3, y plus 2? That's a translation, because we are sliding it down 3, or to the left 3 and up 2. And when you have xy, negative x, negative y, what does that give you? A reflection over the origin. But it can also be a rotation of 180 degrees. I will put this cheat sheet up for you guys. I hope that all helps you out, and I hope you're having a wonderful day. Good night.